Welcome back to Talk Tensors, everyone. I'm so excited for this deep dive today. We're going to be looking at AgentSafe safeguarding large language model-based multi-agent systems through something called hierarchical data management.
Oh, this is a good one.
It is a good one. So as AI agents are becoming more and more integrated into our lives, we have to think about the security of these systems.
Absolutely. And this paper is really timely because it addresses a critical challenge that's emerging as multi-agent systems, MAS, become more widespread. It's all about making sure that these AI systems don't turn into security nightmares.
Okay, so just to lay it out for our listeners, the big idea here is AgentSafe, right?
Right.
And this is a framework that's designed to bolster security in multi-agent systems by ranking information based on its sensitivity. So only the appropriate AI agents have access to that important information. It's kind of like, those top secret government facilities with different clearance levels.
Yeah, that's a great analogy. What's so innovative about AgentSafe, though, is it's moving beyond those traditional security approaches. Those older methods just couldn't keep up with the dynamic nature of these large language model-based multi-agent systems. I mean, those older systems were built for a different era of AI, where agents had very defined roles and communication was carefully controlled.
So it's like trying to stick a square peg in a round hole, trying to apply those old security methods to these new, more complex systems.
Precisely. And that's where AgentSafe really shines. It's introducing this new paradigm of security-level-based information management. And it's specifically designed for the complexity of modern multi-agent systems. So instead of treating all information the same, it recognizes that some data is much more sensitive and requires stricter protection.
Yeah, so it's prioritizing that security based on the value of the information. You really want to make sure that those crown jewels are under lock and key.
Exactly. And AgentSafe does this with two main components: ThreatSeave and Hierarchash.
Ooh, great names.
Yeah, they're very evocative, aren't they? So ThreatSeave is like the ever-watchful security guard, constantly monitoring the communication channels between agents. And it verifies each agent's identity, making sure they have the proper clearance level before any information exchange can happen.
Okay, so it's like that digital bouncer at a super exclusive club, making sure that nobody's sneaking in without those credentials.
Exactly. And then we have Hierarchash, which is this really ingenious memory management system. It's designed to protect the information stored in each agent's memory. So think of it as a really sophisticated filing system that organizes data based on its sensitivity level with multiple layers of security, and it even has a dedicated junk drawer for irrelevant or potentially harmful information.
Wow. Okay, so we have ThreatSeave guarding those communication channels, and Hierarchash is protecting the data itself. It sounds like a pretty comprehensive system.
It is, and the authors actually put it to the test. They didn't just propose it theoretically. They tested it using various large language models like Llama, different versions of GPT, and some custom-designed datasets. And the results are really impressive. They found that AgentSafe outperformed traditional security measures by a significant margin, with a defense success rate of over 80% in all sorts of adversarial conditions.
That's a pretty compelling argument for its effectiveness, for sure. But I think to fully appreciate the impact of AgentSafe, it helps to take a step back and look at how multi-agent systems have evolved over time. Kind of like appreciating a masterpiece by understanding the artistic movements that led to its creation.
I absolutely agree. The concept of multi-agent systems has actually been around for decades. Early research going back to like the 80s and 90s focused on what we now call traditional MAS. These systems were often very meticulously designed for specific tasks, so each agent had a very clear role to play and operated under strict communication protocols.
So it was like a carefully choreographed dance where each agent knew their steps perfectly.
Exactly, and these systems worked great for what they were designed for, but they were also quite rigid and inflexible. So as AI technology advanced, there was this shift towards more dynamic and adaptive approaches.
Makes sense.
Decentralized architectures became more popular, and learning algorithms. And this allowed agents to learn from experience and adjust their behavior based on what other agents were doing.
So it's like those agents went from following a script to improv on the fly, which I imagine increased their capabilities, but probably also introduced some new security concerns.
Absolutely. These dynamic systems were harder to control and predict, which of course created opportunities for malicious actors to try to exploit vulnerabilities. And then you have the rise of large language models like GPT-3 and beyond.
Oh yeah, the LLMs, they're changing everything.
They really are. They gave agents this incredible ability to process information, generate text like humans, and even reason about abstract concepts. But at the same time, LLMs brought their own set of security risks because they are susceptible to certain types of attacks, things like prompt injection or data poisoning.
Okay, and this brings us back to why AgentSafe is so important.
Right. Those older multi-agent system frameworks just weren't designed to handle the security challenges posed by large language models. But AgentSafe steps in to bridge that gap, providing that robust, adaptive security solution specifically tailored for these modern LLM-powered multi-agent systems.
So it's like the missing piece of the puzzle, the security upgrade that allows these incredibly powerful LLM-based multi-agent systems to operate safely and responsibly.
Precisely. AgentSafe is a real game changer, not only because it addresses the security concerns we have right now, but it also lays the foundation for securing even more sophisticated and interconnected multi-agent systems in the future.
Okay, so we've laid out the basics of AgentSafe and how it kind of fits into the evolution of multi-agent systems. Now, in part 2, we're going to dive into the nitty-gritty of how this framework actually works. We'll take a closer look at the two key components, ThreatSeave and Hierarchash.
Sounds good. Looking forward to it.
I am too.
Welcome back to Talk Tensors. Let's unpack the inner workings of AgentSafe, and I think a good place to start is ThreatSeave.
Yeah, so last time we talked about ThreatSeave being kind of like this vigilant security guard for our multi-agent system. But how does it actually work? How does it determine which agents are trustworthy and which ones are maybe, not so much?
Well, it uses two main functions, permission control and message legitimacy evaluation.
Okay.
So permission control is kind of the first line of defense, right? It makes sure that agents can only talk to others who have the right security clearance.
So it's like a hierarchy where only those with the right level of access can actually view or share sensitive information.
Yeah, precisely. But permission control, it's not enough on its own. That's where message legitimacy evaluation comes in. This function looks beyond just checking credentials and actually analyzes the message content itself.
Okay, so it's not just about who you are, but what you're actually saying, right?
Yeah.
Because even a trusted agent could be compromised or try to share information that they shouldn't.
Exactly, and this is where large language models can really shine. ThreatSeave actually uses LLMs to analyze the message, and it looks for any inconsistencies, red flags, anything that seems off.
It's like having a super smart AI detective kind of scrutinizing every single communication, looking for clues of malicious intent.
That's a great way to put it. ThreatSeave looks at the message structure, the language, even the sender's past behavior to figure out if the message is genuine and if it aligns with their expected communication patterns.
Okay, so ThreatSeave is doing a lot of work to secure communication between agents. But what about the information that's already stored in the agent's memory? How do we protect that data from being accessed or manipulated?
That's where Hierarchash comes in.
Ah, yes, Hierarchash.
This component is all about protecting the integrity and confidentiality of the data that's stored within each agent's memory. And it uses a multi-layered approach to do this. It starts by actually dividing the agent's memory into different layers.
Okay, so instead of having this one big pool of memory, it's more like a series of compartments, each with a different level of security.
Exactly. So the really sensitive information, the stuff that needs to be totally under wraps, that's stored in the highest security layers. And it's only accessible to those agents that have top-level clearance. And then less sensitive information is stored in those lower layers where access is more open.
This is reminding me of those spy movies where you have to go through multiple layers of security to get to the most sensitive areas.
Great analogy. And this hierarchical structure is so important because it means that even if an attacker manages to break into a lower level agent, they can't access the most critical data. You contain the damage, right? You prevent that widespread breach.
Okay, that makes sense. But what about information that's not necessarily sensitive, but it's irrelevant or potentially harmful?
Yeah.
How does Hierarchash deal with that?
Well, this is where the junk drawer idea comes in.
The junk drawer, I love it.
It's this dedicated space within Hierarchash, and it's for information that doesn't fit neatly into any of those defined security layers.
It's like that drawer we all have where we just stash random stuff. We don't know what to do with it. We just put it in there.
Right. But in this case, the junk drawer actually serves this really important security purpose. So anything that ThreatSeave flags as suspicious or Hierarchash determines is irrelevant or potentially harmful, it goes straight into the junk drawer.
So it's like this quarantine zone for potentially dangerous information, and that prevents it from polluting the agent's memory and influencing their decisions.
Exactly. But it gets even better. The junk drawer isn't just this passive storage. Hierarchash actually uses this periodic detection and isolation mechanism to regularly scan the junk drawer.
Yeah.
Just double checking, making sure nothing slipped through the cracks.
So it's like having these routine security audits, right? Just making sure everything's still locked down and no harmful information has managed to sneak out.
Exactly. And if something does seem suspicious during these checks, well, Hierarchash can take action. It can move the information to a higher security layer, delete it completely, or even send an alert to a human operator. Just in case.
It's like having a dedicated team of security analysts working 24/7, making sure that only the good stuff, the trustworthy stuff, gets to those agents.
It's a pretty elegant system. So you have ThreatSeave working on the front end, guarding those communication channels, and then Hierarchash is there in the background, managing the data, making sure everything is organized and secure.
Okay, so they work together beautifully. But how do we actually know that this works? How did they put AgentSafe through its paces?
Well, they ran a whole series of experiments using various large language models and custom-designed data sets to simulate real-world situations. They wanted to see how AgentSafe would perform against two main attack types: topology-based attacks and memory-based attacks.
Oh, let's talk about those. What exactly is a topology-based attack?
Well, a topology-based attack exploits the way the multi-agent system is structured, the network. The attacker basically tries to manipulate the communication channels to get to sensitive information.
So instead of directly attacking the agent's memory, they're kind of sneaking in the back door.
Exactly. Imagine a hacker trying to get into a company's network by compromising, say, a low-level employee's account. Then they use that to move up the chain of command.
It's like a digital espionage game, sneaking in, trying to get to the good stuff.
Exactly. Then you have the memory-based attacks, which are more direct.
Okay.
Here, the attacker is trying to manipulate or poison the information that's already in the agent's memory.
So it's like they're trying to infect the agent's brain with a virus, corrupting their knowledge.
Exactly. They could try to inject false information, delete important data, or even just make tiny changes to existing data, just to mislead the agent and make it do something wrong.
Okay, so those are the attacks. So how did AgentSafe hold up against them?
Well, the results were pretty impressive. AgentSafe consistently did better than systems without it, and it showed significant improvements in defense across all those attack types.
So it wasn't just a small improvement. It really made a difference in protecting these systems.
Absolutely. What's really impressive is that AgentSafe's performance stayed strong even when the number of agents and the complexity of the system increased.
That's really important because, as we were talking about, AI is only going to get more complex. We need solutions that can keep up.
Exactly. And AgentSafe doesn't just protect against attacks, it actually makes the whole system more efficient too.
Wait, really?
Yeah.
How does security translate into efficiency?
Think of it like this. When a system is under attack, it has to use a lot of its resources to defend itself.
Right.
That can really slow things down. It's like trying to work on a computer that's constantly being bombarded with pop-ups and malware warnings.
Oh yeah, totally frustrating. Makes it impossible to get anything done.
Exactly. And that's where AgentSafe comes in. It filters out that irrelevant or harmful information before it even reaches the agent's memory, so the agents can focus on their tasks.
So it's not just about blocking attacks. It's about optimizing the system's performance, making sure that it runs smoothly.
Precisely. The authors found that AgentSafe led to significant reductions in what they call token consumption. That's basically a measure of how much computational power you need to process information. And in some cases, they saw reductions of up to 75% compared to systems without AgentSafe.
That's a huge improvement. It's not just about making it safe, it's making it more cost-effective to run, too.
Exactly. And that focus on both security and efficiency is what makes AgentSafe so promising for the future of multi-agent systems. It's about building systems that are both secure and agile.
So we've covered a lot here. ThreatSeave, Hierarchash, different types of attacks. It sounds like they really put AgentSafe to the test. But I'd love to hear more about the specifics. What data sets did they use? What exactly did those experiments look like?
Yeah, let's get into those details. In our next segment, we'll dive into that experimental setup and see how AgentSafe performed in different scenarios. And maybe we can even pull in some real-world examples to show how this framework could be used.
Welcome back to Talk Tensors. We've been deep diving into AgentSafe, exploring all the ways it helps secure those multi-agent systems. But I'm thinking now, where do we go from here? What's next? What are the potential future directions for this research?
That's a fantastic question. And actually, the authors do address this a bit towards the end of the paper. While AgentSafe is a big step forward, it's mainly focused on reactive security, defending against attacks that we already know about.
So it's like, we've got this amazing security system, but what happens when some brand new threat pops up, something nobody's ever seen before?
Exactly. And that's why I think one of the most exciting areas for future research is to develop more proactive security measures. The authors even suggest this idea of an AI immune system for multi-agent systems.
An AI immune system. Oh, I love that. So instead of just reacting to threats, the system is learning, adapting, and it's finding those vulnerabilities before they can even be exploited.
Exactly. Just like our own immune system, it's constantly learning and evolving to fight off those new pathogens. An AI immune system would be designed to anticipate and respond to all kinds of threats, even those we haven't seen yet.
That's amazing. But how would we even begin to build such a system?
Well, it would definitely require a multifaceted approach. I think one key element would be really advanced anomaly detection. So the system would be constantly monitoring the behavior of the agents and looking for anything that deviates from normal patterns. Anything unusual could be a sign of an attack or a malfunctioning agent, which would trigger further investigation.
So it's kind of like those super sensitive security cameras, always scanning for any suspicious activity.
Precisely. But it goes beyond just detection, right? We also need sophisticated threat modeling, which involves anticipating those potential attack vectors based on how the system is built, what kind of data it handles, and the vulnerabilities of the LLMs.
So you're saying we need to simulate those attacks, see where the weaknesses are, and then we can develop countermeasures.
Right, like having a team of ethical hackers always probing the system, looking for any chinks in the armor.
I like it.
And then finally, those self-healing mechanisms are going to be crucial. So the system will be able to detect, identify threats, and then automatically take steps to neutralize them.
Oh, so if there's an attack, the system could automatically isolate the problem, quarantine data, and even start repairs to prevent more damage.
Exactly. The goal is to have a system that's secure and resilient. It can recover quickly and adapt to those new threats.
Creating this AI immune system would be, well, a huge undertaking, but the benefits would be immense. This could be revolutionary, not just for multi-agent systems, but any AI that's interacting with the real world.
Absolutely. And there are other interesting paths forward, too. The authors mention this idea of using blockchain technology to increase security and transparency in these multi-agent systems.
Blockchain, that's like the tech behind Bitcoin, right?
Mm.
I'm not sure I see how it would fit in here.
I know, it's a bit of a jump, but blockchain has some unique features that could be so valuable. For one, it's immutable. So once something's recorded on the blockchain, it can't be changed or deleted.
So it's like a permanent tamper-proof record of everything happening in the system.
Exactly. That's perfect for audits, ensuring accountability, and stopping bad actors. Imagine a system where every communication between those agents, every access to data, every decision, it's all recorded on this blockchain. There's a trail.
Like a built-in surveillance system, always watching.
Exactly. And this level of transparency, it can really build trust between those agents. If there's a problem, you can go back and trace everything, see what happened and who was involved.
That's a really cool idea. Like having a perfect memory of everything that's ever happened. No room for doubt.
And you can take this transparency even further with a decentralized reputation system for agents. So agents who do the right thing consistently, follow the rules, they build a good reputation. Those who act suspiciously, their reputation goes down. And this reputation score, you can use it for decision-making, giving more power to the trustworthy agents.
Wow, that's pretty amazing. Like a built-in system of checks and balances where the agents themselves are keeping each other honest.
Exactly. And when you combine that with the hierarchical security model of AgentSafe, well, you've got the potential for a really robust, trustworthy environment for multi-agent systems.
I feel like we've only scratched the surface of what's possible when it comes to securing these powerful AI systems.
I agree. And it really shows that AI security is not just about the tech, it's multidisciplinary. You need computer science, cybersecurity, even ethics and psychology to really understand these systems and come up with solutions that are both effective and, well, human-centered.
This paper and this deep dive, it's been a fantastic journey into the world of multi-agent security. AgentSafe is a huge step forward in making sure we can use AI safely and responsibly.
Couldn't have said it better myself.
And to all of our listeners out there, if you want to learn more, check out the full paper. We'll put a link in the episode description.
Definitely do that.
And thanks for joining us on this deep dive into AgentSafe. Until next time, keep exploring, keep learning, and keep pushing the boundaries of AI.